follow the same rules of Android. You should not block the main thread. Why? If you don't have a UI, you don't need to refresh the UI, right? However, you have events, like keyboard events, that can still be sent to your application, to your main thread. You have sensor events. So you have a bunch of other stuff so you should not block the main thread. That's a main rule for Android, and that is something we are doing here. So let's fix that. The way I'm going to fix this, there are multiple ways to do it. You guys probably know you can create a service. You can create a thread. I would do it the simplest way here. I just create a handler, attach that handler to the main thread, and add each set value to the end of the looper, of the main thread looper. It's going to look less complicated than it sounds.
So as Renato mentioned, one of the things that we're doing is we're ensuring that the main thread in Android continues to remain free so that system events can still come into your application, whether those are lifecycle events or he mentioned input events. This also means that in general, if you have to do any regular polling of an input or something along those lines, you want to make sure that you don't do that on the main thread either. So in this case, we're scheduling an output, so the way that we're doing this is fine. But if we need to poll a sensor or read some value from another input on a regular basis, we might actually want to use a background thread to do that. Now, it could be a handler thread. That seems to be the simplest way to sort of modify what's being done in this case. Or you could use async task or other things that suit your development workflow, because it's just Android. They all work the same way you expect. But it's important to realize that when you're working with some of this hardware, it's still good to offload those regular, repeated, long-running operations off the main thread, even though it's not a network access or something that you might otherwise traditionally consider as one of those blocking operations.
OK, good job.
Yep. Sorry.
And now we have the code that supposedly should work. Again, let's cross the fingers again. Actually, first let me just go over it pretty quickly. I have the handler. The difference between now and before is that now I have a handler, and the handler like sliced all the work that the looper was doing, the while loop was doing, into this method, run and reschedule. It does exactly the same. However, at the end, it posts itself at the end of the looper. So it can do whatever it has to do, like a reading sensor or reading keys, processing any event that's coming to the main thread, and then it does another step, and then it reschedules again. Again, this is not specific for Android things. This is Android. And you won't know if it's working or not, so because it was blinking before. I would change the LED to the green one, so you don't have to trust me. Done.
There you go.
Awesome.
All right. That's good.
It's OK now, right?
It's good looking code. I think we're following a good pattern here.
OK, bye-bye.
Well, I mean, we work for Google. I feel like we should be able to do a little bit better than just blink a light on stage. You said something about sensors and displays on this board. Can we get something a little more interesting going? OK,
we can do that. We can do that. So as I mentioned, there is one sensor, one main sensor in this board, which is this tiny thing here. Can you see it? Right here. It is the BMP280. It's a temperature and ambient pressure sensor. And we can easily connect to that using the Rainbow Hat driver. So let's do it. And what I'm going to do is not only read from the sensor, I will also show the results, like the temperature, on this segment display here, right?
I think that's a better demo.
See? And how am I going to do that? That's really easy.
So what you may have noticed already is earlier in the presentation I talked about interacting with a lot of these things using low-level buses like GPIO, I2C, et cetera. And none of that is actually in this code. The reason for that is that the driver that we've written for this specific peripheral, the Rainbow Hat, abstracts all of that away. So there's two reasons that we're showing you this. First of all, that using these drivers is a much faster way of getting started without necessarily having to deal with all those low-level details. But these drivers are also open source on GitHub, and we'll mention a link to that a little bit later on. So you can also use them as a reference to see how to build something with these abstractions using those interfaces directly, and you can read that code. Are you done yet?
Yeah, of course.
Oh, okay.
You take too long talking. So on the onCreate, I initiate the driver, and I initiate the display with a few default values. And here in the loop, I will keep the LED so you see that it's processing. And I will display on the display the sensor value, read temperature. And that's it. Done.